All right, an angle is in standard position. If its vertex is the origin and its initial side lies on the positive x-axis. So what that means is if I draw the x and y axis, this is called the initial side, and where you're rotating to is called the terminal side. And it's in standard position if you're starting with the initial side on the positive x-axis. Note, positive angles rotate counterclockwise, negative angles rotate clockwise. Something I need to mention is if you don't rotate at all, that's 0 degrees. If you rotate up here, that's 90. Here's 180. 270, and a full rotation going all the way around is 360 degrees. So, if I want to draw an angle in standard position and I have 240 degrees, what we're going to do, we're going to start with a little grid here. Here I am starting. Now remember, to go to 240, I've got 90, 180, 240 is more than halfway. Positive angles start at the positive x-axis and rotate counterclockwise. So then, if you think about it, you may have wondered, why do we label first quadrant over here? Why didn't they start over here in the left? And it has to do with angles. I'm going to recalibrate them off here a little bit.
I remember whenever you were going over this with Bella and pre-calculus and stuff like that, the counterclockwise and the clockwise stuff.
You do remember that? Okay. So now, let's look at 500 degrees. Well, wait a minute. Going all the way around once is 360. So I've actually gone more than one time around. Well, we need to figure out how much more around. So you take 500 minus 360, and that's 140 degrees. I want to mention, I'm not expecting perfection at all. However, what's halfway in a quadrant? How many degrees is half? 45. So I do expect it, if it's 60 degrees, you shouldn't be drawing it down here where it looks less than 45, okay? So just a little bit more, a little bit less, about the middle. Again, not perfection. But I'm going to stop and think about 140 degrees first. 140 degrees, isn't that 40 degrees away from 180? So that's really close to the halfway mark. But then watch how I'm going to show 500 degrees. You're going to start here. Positive angles go counterclockwise. So I went one whole time around like this. And then you label your angle 500 degrees, okay? Then let's do letter C, negative 50 degrees. So here's my angle starting on the positive x-axis. Now I'm going to go clockwise this time. And it's negative 50 degrees. I also want you to notice that I draw an arrow with my arc because that's indicating the direction. Okay, angles have a direction that you rotate. All right, any questions on how you draw an angle? This is foundational to what's coming. Any questions? All right, I keep forgetting that I put the doc at the bottom. All right, here's another definition. Angles in standard position with terminal sides that coincide are called coterminal angles. So let me give you an example. If I start with a 60-degree angle, coterminal means they have, it's in standard position, so they're starting at the positive x-axis, but they have the same terminal side. That's why they're called coterminal angles. So another would be, I could go all the way around, so 420. Do you see how that's coterminal? It has the same stopping side. The other one I could do is I could start here and go in the negative direction. What would be that negative angle if I'm rotating all the way around? 300, good. And it's actually negative 300. So 60 degrees, 420, negative 300 are coterminal angles. And there's actually infinitely many. You can just keep whipping around and around and around either direction. Here's what I want you to do over in this space here. I want you to come up with two coterminal angles. You pick a first one, anything you want. I want you to do it over here. And then come up with one that has the same terminal side to it.
How many different angles do you want each one to have?
Now I want you to come up with one angle and give me one coterminal angle.
Oh, okay.
Alright, anybody have one they want to share? Noah, what do you have?
I don't know if it's right.
Go ahead and give-
380 degrees.
You did 380 degrees, so let me draw that one first. So 380 is 20 degrees more than one time around, okay? And then what was your second one?
20 degrees.
That's it, okay. Do you see that? They have the same terminal side. All right, how about another pair? Who else has one? Carmel?
45 degrees.
Okay, 45 degrees. Let me pause and draw that one first. All right, so it's smack in the middle. Okay, what was your other one, coterminal?
315.
Well, it can't be 315 because that'd be over here. You mean around this way, right?
Yeah, negative.
Negative. There you go. There you go. Okay. All right. Do you guys see? We just came up with two other pairs of coterminal angles. So Carmel's is a nice one here for example 2, letter A. If I have negative 45 degrees, so negative 45 degrees is actually in the fourth quadrant. Are you guys noticing a pattern here? What could I do to always get another coterminal angle?
Add or subtract that number to 360 or 0.
Okay, you're going to, all right, so let's write this down. To find a coterminal angle, you just take your angle plus or minus 360 degrees, but you have to start with the angle first. You don't take 360 minus or 360 plus. So, what I can do, I can add 360 degrees. That's 315. Now that's a positive angle. We need a negative angle, so let's now subtract 360. And I got negative 405. Now, I'm not saying that you take your angle and add 360, you take your angle, subtract 360. I'm not saying that you do one of each time. I'm saying to get another coterminal angle, you can add 360 produces one, or subtracting. So like in letter B, I have 395. I don't really want to add 360. I can, but do you understand that if I subtract 360, I don't have a negative coterminal angle yet. So in this case, I'm going to want to subtract twice. Instead of, you don't always add and then subtract. That's not true, and I'm not saying that. But the first time I subtract, I still have a positive. And so in this case, and see, do you understand it said find one positive and one negative? That doesn't mean you add one, subtract one. And this, sometimes you can add 360 twice if it's a pretty big negative angle. All right, does that make sense? All right, radian measure. Angles are measured in degrees, but they can also be measured in radians. What I want to point out to you is, do you know how you can measure distance in miles and you can measure them in kilometers? Those are two different types of systems of measurement. You have the metric system for kilometers and you have the U.S. customary system that would be miles. Well, we have a similar situation with the measure of angles. Angles are measured in degrees or radians, so you'll get comfortable with these this year and next year in pre-calc. Well, one time around a circle is 360 degrees. Well, in radians, that's equal to 2 pi. So what we have, here's our conversion factor. 2 pi is equal to 360 degrees. So if I divide both sides by 2, pi radians is equal to 180 degrees. So that's my conversion factor. So it says if you want to convert from degrees to radians, you take pi over 180 degrees, and that will put it in radians, and you just multiply. And to convert from radians to degrees, it's 180 over pi. And let me help you out in your science classes. I would think you'd be doing unit conversions like moles and stuff like that. This is actually very, very simple. Whatever unit you're going for, like you're trying to convert it into that unit, you want to multiply by, so say you want moles, then you're going to multiply by moles over whatever it's equivalent to. Because you want that one to cancel, so it has to be in the denominator. The one you want has to be in the numerator. So that's how you do all unit conversions. It's very, very straightforward. Okay? So now, I do not want you using a calculator on these, because we've got to learn how to do this without. In example 3, it says convert to radians. I have 125 degrees. So I want to put this in radians, so I want the radian in the top and the degrees in the bottom. So I don't memorize pi over 180 or 180 over pi, I just stop and think. I know pi equals 180 degrees, and I want radians, so the pi goes in the top. That's it. Now, I said I want you to do this without a calculator. We're going to leave pi in our answer. And I notice 125 and 180, they both end in either a 5 or a 0. That tells me 5 goes into each number. So we're going to start there. So 5 goes into 125, 25 times. 5 goes into 180, 36 times. So that's 25 pi over 36. Negative 240, I'm going to multiply by pi over 180. Well, they both end in a 0. That means 10 goes into both numbers. So I'm going to divide by the 10, and that cancels the 0. Then I look at 18 and 24. What's the biggest number that goes into 18 and 24? 6. So 6 goes into 18 3 times. 6 goes into 24 4 times. Don't lose the negative sign. That's negative 4 pi over 3. In example 4, we're going to go in the opposite direction. 5 pi over 6, I want to multiply into degrees. So the degrees go in the top. The pi's cancel. 6 goes into 18 3 times, but there's a 0. So 5 times 30 is 150 degrees. And see how we're doing this without a calculator. All right, try letter B. The pi's cancel. 3 goes into 180 60 times. That's negative 300 degrees. Okay? All right, any questions on radians to degrees, degrees to radians? It's pretty simple. All right, now we have our unit circle, okay? And you've heard the pre-calculus students talk, moan, groan about it. So you are going to learn part of it today, a very small part of it. The first thing we're going to do is we're going to go around the inside of the circle, and we're going to label the inside with degrees, and we're going to go back around on the outside with radians. On the unit circle, and I apologize, this was not supposed to look like they're evenly spaced, but I needed room to write. So what's going to happen on the unit circle, the spacing goes like this. It goes 30, 15 degrees, 15 degrees, 30 degrees. And it does that around all 4 quadrants. It goes 30, 15, 15, 30. Then I'm going to go 30. So that makes it 120. I go 15 degrees, 15 degrees, 30 degrees. Okay? 30, 15, 15, 30. 30, 15, 15, 30. So we're going to go 30 more. That's 210. And I go 15. That's 225, 240, and then 30. So do you see what I mean? 30, 15, 15, 30. And then we're going to go 30 more. What's the next angle? 300. And then what's the next one? 315. And the next one? 330. And then if we go nowhere, it's 0, and all the way around is 360. Okay? So the degrees are equal. It goes, or easy. It goes 30, 15, 15, 30. 30, 15, 15, 30. 30, 15, 15, 30, okay, around. Now, off to the side you have some space. And I need you to write down 3 radian angles. Pi over 6, pi over 4, pi over 3. Okay, do this to the right, far right, okay? Because you're going to need space. We're going to be writing all the way around here. Okay. So now, what I want you to do is I want you to multiply each one of these by 180 over pi, and I want you to convert them to degrees, okay? I want you to multiply each one by 180 over pi. So pi over 6, how many degrees is that? 30. How about pi over 4? 45. Pi over 3? Alright, these are the 3 main angles. And you have got to know them like the back of your hand. What I would strongly recommend you do is get 3 index cards. On the front of the first one, put pi over 6, and on the back, 30 degrees. Second card, pi over 4, on the back, 45 degrees. Third card, pi over 3, the back, 60 degrees. And you need to just, if you hear pi over 6, you think 30 degrees. It's just got to be this natural connection. All right, so what we're going to do is I'm going to choose some different colors, see if I can't make this make more sense. So pi over 6 is 30 degrees. Now, if I add another 30, I add another pi over 6. Pi over 6 plus pi over 6. Don't write it beside the tick mark. We're going to write it out here. Isn't 2 sets of 30 2 pi over 6? But that reduces to pi over 3. Now if I add another 30 degrees, that's 3 pi over 6. But that reduces to pi over 2. Now I didn't forget, but I'm skipping the 45s because they're not multiples of 30, okay? We'll come back to those. Now, I add another 30, that's 4 pi over 6. That's 2 pi over 3. I add another 30, hey, that's 5 pi over 6, and it doesn't reduce. If I add another 30, write it out a little bit further, that's 6 pi over 6. That reduces to pi. I add another 30, that's 7 pi over 6. Add another 30, if I think about it, that's going to reduce. That's 8 pi over 6. So that's 4 pi over 3. Then I have 9 pi over 6. That reduces to 3 pi over 2. I add another 30, that's 10 pi over 6. That reduces to 5 pi over 3. I add another 30, that's 11 pi over 6. That doesn't reduce. And if I add another 30, that's 12 pi over 6, which is 2 pi. So do you see how I did that? I went all the way around. Now, I'm going to handle my 45s. Well, 45 we know is pi over 4. If I add another 45, that's 2 pi over 4, which is pi over 2. If I add another 45, that's 3 pi over 4. I add another 45, that's 4 pi over 4. That's pi. Then I'm here and I get 5 pi over 4. This one's 6 pi over 4, but that reduces to the 3 pi over 2. And 7 pi over 4. And then 8 pi over 4 is 2 pi. Now what's neat about the pi over 4s is there's a little pattern here. It goes pi over 4. If I look at, that's dead smack in the middle of each of the 4 quadrants. And if you look, I wrote that in a black color. That's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So they're odd, 1, 3, 5, 7. So it's kind of easy to remember. So you guys are this is only a little part of the unit circle. We're going to then, with each thing, if you've ever seen somebody with a unit circle t-shirt, there's a whole lot of other things on it. We will eventually find out their coordinates. These are XY points on the unit circle. So there's going to be a coordinate, XY coordinate at every single one of these points. Okay? So let's stop here a moment. Look. Let's think about it. You have to really understand some fraction work.
Good afternoon, and sorry for the interruption. The sophomores who were taking the biology test are